All right, so let's see.
Oh, crap. Give me 1 sec. I'm going to grab my calculator.
Okay, you're fine.
Grab my two actually.
All right. Oops.
All right.
Okay.
So did we choose 5 of them?
Yeah.
Which 5 did we choose?
Oh well, I think we were just supposed to randomly choose them, right?
Yeah.
Yeah, it says random select 5 of the 30 salaries and compute the mean as a group.
Oh, as a group.
Yeah, it says.
I think
I
we're
thought
supposed
we
to
were
do it
supposed
all.
to do that.
Well, it
Yeah,
says
I
you'll
already-
fill this part out during your group preparation session.
Yeah,
Together?
that's true.
Okay. Because
There's
I did.
in
Well,
part
because
D,
I was confused
it
because on
says
number
you're
D,
supposed
it says compare yours to everyone else's.
Yeah.
to
You
3 other
compare your mean
people.
from question 8A.
So
Yeah.
I think we're
Part-
supposed to
part
all
D.
pick our own random 5 numbers,
Okay.
but
Yeah.
we're supposed to wait until the group presentation to do it.
I did not know that. All right.
That's okay. It's super easy if you go into that website that they gave you, the random one.
Or you could probably just pick 5 random
just
ones.
pick 5.
It really wouldn't matter.
Yeah, I guess so.
Yeah.
I just did that random and it just picked all the numbers for me. So
Yeah, mine did that too.
but yeah, just pick 5 and then we'll do the mean and then
Okay.
compare it.
All right. Got that done real quick.
Okay.
Well, that's pretty sweet.
What was everyone else's means?
46,260.
Okay. What was yours? 36,000.
Mine?
46,260, I think is what he said.
Yeah,
46.
46,260.
Okay.
Mine was 47,380.
And I got 42,680.
Okay.
44,540.
44,540.
Okay.
Okay. So, let's see. So if we mark everyone's on there, they are.
Yeah,
I
some are
think
to the right of the mean, like the actual mean, and some are to the left,
Yep.
which just is probably
They're
normal.
all right there. Yeah, they're all right where they're supposed to be.
Yeah.
So
All right. Yeah, so number D, it says, compare your mean from question 7 to the means obtained by at least 3 other individuals. What do you notice? I feel like they all lie right in the middle of the graph.
Close to
Let's see.
approximately the same mean.
They're pretty close.
well, the 42,000 one is pretty far left.
Yeah.
But I think that's normal because if you add all this together and take the mean of the sample means, then it should be close to the actual mean of the population.
Oh, yeah.
Or whatever.
Yeah.
I think isn't that the law of large numbers or whatever?
Yeah.
Yeah, something like that.
Yeah. So with just one sample mean, then we can't really say that it's close. But if we put them all together, it'll be closer.
Mm-hmm.
Yeah.
Okay. Number 8 says, what is the shape of the distribution of sample means for all such samples?
So because the actual test is normally distributed, then any sample should have a normal distribution, right?
Yeah.
Yes.
Okay.
Let's see. B. How do you know the distribution of the sample mean has this shape?
Isn't it kind of what you just said though too? Is that the
Yeah.
parent like basically what it is like the population of it, or like
Yeah.
what the test is normally distributed, so it should be the same thing.
Yep.
Yeah.
Okay. What does it mean of the sampling distribution of sample mean scores for all such samples?
And they give you that. It's 529.
Yeah, 529.
So for some reason this confuses me because the mean of the sampling distribution of sample mean scores.
I know there were so many means in that thing.
Yeah, but so it says that's always true, that the population mean and the sample mean will be the same.
Yeah.
Interesting.
But I thought the law of large numbers was saying that the more sample means you take, then the closer it gets to the population mean. So,
I'm thinking though, with something such as this type of test where so many people take it, it probably is taking that into consideration. Because a lot of people take GMAT,
right.
so
Yeah, I don't know. I don't know why, because, like you say, with the law of large numbers, that the more you take, the closer it gets. But it just says the following facts are always true, that the mean of the sample is the same.
Yeah.
So I don't know.
Because what was this? What we did at the very beginning, where we had to pick the random sample out of those, and then when we took our mean, it was not the same as the population mean.
Yeah.
So what's that's what I'm confused is what the difference is between this mean and the mean we did up there. Like how are those different?
I have no idea.
that's a good question.
That is a good question.
But anyway, all we know is that it is 529, so it is the actual mean of the parent population. So I don't know why.
Yeah.
It works.
Yeah.
It might just be one of those rules.
All right. I know. That makes no sense, but you just do it.
That's what I'm hoping it just works every time.
I know.
Yeah.
All right, number D, or letter D. What is the standard deviation of sampling distribution of the sample mean scores for all such samples? So you take this standard deviation, which is 113.
Then you do it the sample. What is it,
and then divide it by the square root of 10.
Yeah, because that's sample size.
Yeah, square root of 10.
And you get 135.734, right?
Yeah, 35.734.
Yeah.
That's what I got too.
Okay.
Yep. Alright.
Well, you guys ready to take a quiz?
I guess
Do
so.
this again.
All right. Let's do that. Okay. So number 3, is everyone there?
Yeah.
I'm getting into it right now. Sorry.
Okay. No, you're
There
fine.
we go. I'm there now.
Okay. So number 3 says, when taking samples of n when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed?
So it should be right skewed until n is like greater than 30,
20.
right?
30.
Yeah, that's what I thought.
Yeah,
So
greater
would
than
it still
30.
be skewed right then?
I think so.
Yeah.
Because it's not normal for sure, because normal only comes after the sample size is big enough. And I don't think it would be left skewed.
Mm-mm. Okay, so skewed right?
Yep.
Yeah.
Okay. Number 4, when taking samples of n equals 100, what is the shape of the distribution of means histogram when parent population is right skewed? Isn't that normal because it's now higher?
Yeah, I think that should be normal.
Yeah.
If I understood the reading right, anyway.
Yeah. Okay. Number 5, when taking samples of n equals 100, what is the shape of the histogram when the parent population is normally distributed? Isn't that normal?
Yeah.
Okay. Number 6, when would the distribution of means be normally distributed?
So anytime that the population is normally distributed, or if the data is a large sample.
Large.
So we should mark 3 of those, right?
Okay, so
Yeah. I'd say the first, second, and fourth one are all right.
Yep.
let's make sure that these are all the same. Because they might be.
So the only one you don't pick is that the data are drawn from the population that's right skewed and the sample size is small.
Okay.
Yeah.
Everything else should be true.
Yeah.
Okay.
I swear that happens every week. I'm sorry.
Oh, you're fine.
Just like shuts off.
No.
Alright, so where are we at?
We're at number 6. Are you caught up?
No, I don't, what was number 5? Sorry.
Okay. No, you're fine. It's normal.
Okay, that's what I thought. I just wasn't sure.
Okay.
Okay, what would the distribution mean to be normally distributed?
Okay, and then number 6, it's all of them except for the data are drawn from population that is right skewed and the sample size is small. So 3 of them should be checked.
What about the one where it says data drawn from population is right skewed and the sample size is small?
That
That's
one's
the
not.
only one you don't pick.
That's not true.
So, okay. Okay, sorry. So the one that says is normally distributed and sample size is small is also normal though, right?
Yeah.
Yep.
Okay.
Okay, number 7. Which of the following gives the best explanation of the central limit theorem?
Let's see.
So it's not the bell-shaped data because that's the
Mm-mm.
68, 95, 97 rule or whatever.
Yeah.
And I think if the sample size is large, the sample mean will be close to the population mean as the law of large numbers.
That's the law. Yeah.
Mhm.
So it's either the parent population is normally distributed, then it will follow normal distribution, or if the sample size is large, the shape of the sample mean will be approximately normal.
Yeah, I would guess the last one, just based on
Yeah, so I found
Sample
the
size is
definition.
large.
sample mean will be approximately normally distributed.
Yeah.
That's
So
what I
large,
think.
yeah, I found a
So-
definition for it, and that's what it is. So
Okay.
All right, number 8. Let x be a random variable with population mean 10, standard deviation 6. Okay, so we have to find the mean, which is 10.
Yeah.
Right.
According to whatever rule they use.
According to
Yeah.
this rule. Okay, what's the standard deviation? All right, so this one we have to actually.
Should be 6 divided by the sample size, the square root of the sample size.
Uh
Should
huh.
be 1. 6
So
divided by.
1.
yeah,
So what's the 3 decimal places?
1.0000.
Okay.
that's weird.
She would do that.
Yeah.
What? So mean of the distribution was that 10 for the first one? Sorry.
Yeah.
Okay.
Yeah. It should. Apparently, it's always the same as this population mean.
Easton, quiet. Sorry.
He's talking to
Sorry,
Daddy.
guys. I know. Doesn't want me. He's okay. So number 10. Regardless of the distribution of the population, if the sample size is large, what would the shape of the distribution of the sample mean?
It would still be normal if it's
Normal.
Yeah.
Yep.
And that's
And
the
then-
central limit theorem still, right?
I think so
If
because
the
that's
sample
what.
size is large.
Yeah, if the sample
Yeah.
size is large and you're in a normal distribution, it's just a normal theorem.
Okay.
Yeah.
All right. Do you want me? I can do it. All right. Let's see. Okay. We got an A, 100%.
Sweet.
Nice.
Perfect.
Okay.
All right.
Okay.
All right, guys.
All right. Have a good one. Wednesday, right?
Wednesday at 8:15.
8:15.
All right.
Yep.
Okay.
That's good.
Good.
See
Sounds
you then.
good.
All right. Thanks, guys. See ya.
See you
Yep.
guys.
Bye.